Right, welcome everybody to the final IRDR monthly seminar, actually of the year. Always most welcome to join us here, and both on Zoom, and to many of you who are also joining us now or later on the YouTube channel. Delighted to have Elisabeth Krausmann here today, who I'll introduce just in a moment. But I just wanted to say a couple of things first before I start on that. Just a reminder that even though this is the last of our monthly seminars, on the 24th of March at our Wednesday lunchtime discussion forum, we're also inviting the master's students to a sort of a special discussion, which is going to be led by Olivia Harris. Olivia Harris is actually a graduate from our MSc Risk and Disaster Science program, and actually she leads the secretariat of SAGE, which you've probably heard quite a lot about over the last year, because of the sensitivity of SAGE, that actually there's a special registration process, because that there are certain restrictions about sort of not having journalists there and things like that. But do come to that on Wednesday the 24th of March. Just want to say something technically about just a reminder about asking questions. Elisabeth will talk for about half the time, and then there'll be a pause for questions, and then she'll resume talking for the other half time, and there'll be another opportunity to ask questions at the end. So to ask questions, please type your questions into the Q&A box, and then I will read them out. And that's also then in that case the people joining on the YouTube channel can also hear the questions as well. So you can type your questions into the Q&A anytime, and then I'll pick them up during those two question and answer periods. So just sort of to introduce Elisabeth, she is a scientist with the European Commission Joint Research Centre. She was a Marie Curie Fellow at the JRC and has a PhD in physics from Vienna University of Technology, specializing in nuclear physics and nuclear engineering. Her research experience includes risk analysis and management of natural hazard impacts on industry and critical infrastructure, nuclear reactor safety, and severe accident management. And since 2006, she's led the Natech project at the JRC, which focused on developing methodologies and tools for risk analysis and mapping lost data on developing methodologies and tools, on a collection of forensic analysis and capacity building. So I think with that, then I shall hand over to Elisabeth, and please, you're most welcome. So really looking forward to your seminar. Thank you.
Thank you very much, Peter, for this introduction. I'm very honored to be able to speak to you today and show you a little bit of the work that we're doing, and to introduce you in case you didn't know anything about Natech risks, so-called Natech risks, which is when natural hazards trigger technological accidents. And these kind of accidents, or this kind of risk, has been receiving more and more attention because of several really bad accidents that got a lot of visibility. For example, in 2000, there was the Bayamare tailing stem accident. A tailing stem of a metal mine broke due to heavy rainfall and snow melt, causing a transboundary accident, polluting several rivers in different countries. Or in 2002, we had in a country very bad flood-related Natech accidents, chlorine releases. So these were a bit of a wake-up call in the European Union, putting Natech risks into people's minds, and also leading to legislative changes to better account for this type of risk. And then, of course, in 2011, the Fukushima accident put Natech risks on the global agenda. And so I'd like to talk to you about this topic today. I don't know what your background knowledge is, specifically related to Natech risks. So I've decided to just give you a basic introduction, but if you want some more in-depth knowledge or some more detailed discussions, just let me know. Okay, then I'll start sharing my presentation with you, which is gone. That is very weird. Jasmine, can you help?
Hi, Elizabeth.
Let me try again because it worked before. Okay. Yeah, here it is. Now it's here. Sorry about that. Okay, all right. So, as I said, I'll be talking about Natech risks, which I have termed also when the natural and technological worlds collide, because in the very sense of the word, this is literally what's happening. And in my presentation today, I'd just like to tell you very briefly who we are, meaning the Joint Research Center of the European Commission. I'd like to introduce Natech risks and then some of the activities that we have been doing here at the JRC in collaboration with other research institutions. And then I'll just tell you what is missing to close gaps that unfortunately are still remaining to achieve proper Natech risk management. So what is the JRC, the Joint Research Center? We are the European Commission's Science and Knowledge Service. So what we do is when it comes to, foresight or the conception, development or implementation of EU policies, we are called upon to provide scientific support. So evidence-based support throughout the whole policy cycle. The Joint Research Center is located in 6 places in 5 EU member states. I'm based in a place called Ispra in Italy, in the north of Italy, which is the biggest site of the Joint Research Center. And overall, the JRC has about 3,000 staff, of whom about 1,500 are researchers. And in terms of research topics that we are addressing, I've listed here the issues that we are handling. So we are looking basically at everything that is of policy relevance. My department is in the Space Security and Migration Directorate, where you see the different departments we have here, or the different units. We have a disaster risk management unit with whom we collaborate very strongly. However, the Natech activity is in the unit which is called Technology Innovation in Security. So I'd like to start with this image here, which is a collection of different Natech accidents caused by all different sorts of natural hazards. So we have flood, we have storm, landslide, tsunami, lightning. So this image basically, and I like to show it because it very graphically shows what can be the problems of Natech accidents. Because on the one hand, you have the issue of damaged infrastructure, economic losses, in terms of loss of production, downtime, and so on. But you also have a huge problem related to health impacts due to the releases of hazardous substances and environmental impacts. And here is the definition that we use. So a natural hazard triggered technological accident is what we call a Natech accident. So you have natural hazard impacts on some sort of hazardous facility or hazardous activity, which stores, handles, or houses hazardous materials. These materials can be toxic, they can be flammable, they can be explosive, they can also be radioactive. So we have at the GRC, sorry, predominantly been working on chemical accidents, chemical Natech accidents, but of course Fukushima was also a Natech accident. So just to have the definition here. Now, why are Natech accidents such a problem? Can they not be treated like any other kind of traditional technological accident, like a chemical accident? The answer is no, because we have several issues that are very, very specific to Natech accidents and which result in a very complex and difficult response environment. And let me just show you the main issues here. So take the example of an earthquake hitting an industrial park. So you don't only have a hazardous material release or damage and a release from a single point source, but you can have releases from single or multiple sources over wide areas, and that at the same time, simultaneously. So this is a problem, of course, and this is an example from the Great East Japan earthquake and tsunami in 2011. This hit the refinery and triggered fires in several places at the same time at that refinery. So this is a huge issue for emergency response, as you can imagine. The other issue is that if you have an accident, you need certain lifelines for accident mitigation. For example, you need water for firefighting, but you might not have that during a natural disaster, for example, because the natural disaster affects your lifelines as it affects the hazardous industrial facility causing a Natech accident there. The natural disaster also affects safety barriers that you might have, so you cannot rely on them being there. And this is just, well, an example of power blackouts caused by a very severe hurricane. And blackouts can actually also cause Natech accidents. Think Fukushima. Then, so during a Natech accident, you have usually a natural disaster and a technological accident, a chemical release. So where do you go to respond? You know, you get competition for scarce response resources. This is a real problem, and I put this image here, which is a little bit extreme and provocative, but you have limited response resources. Where do you send them? Do you send them to combat the technological accident that is maybe at risk of cascading onto neighboring facilities, or do you send them to rescue people trapped in collapsed buildings? So if we're talking about earthquake, in this case, for example. Another issue is that the toxic releases, for example, fires or explosions, can hamper emergency response, because these effects, these fires, these explosions, they can also endanger rescue personnel. At the same time, they can also endanger disaster victims. So what we have seen sometimes that happened is that if first responders came in, you know, for search and rescue operations, that in some cases they had to evacuate, leaving people buried under the rubble, because next door was a very bad Natech accident developing, and there was a risk to the emergency responders as well. And the last point I want to mention here is usually when you have chemical accidents, for example, the standard approach to protect people would be to tell them to stay in the house, to close the windows, to use duct tape, you know, along the windows and so on. But you cannot do that. You know, if taking again the example of an earthquake, you cannot tell people to shelter in place in a building like that, because the structural integrity of that building might not be okay anymore. Or another approach is to evacuate, but then depending on what happened, which natural hazard has actually caused the Natech accidents, you might not be able to evacuate. Imagine whole areas of land being flooded, causing a Natech accident. How do you evacuate people? So this is a big issue, and this is why Natech risks really need to be considered. You need a dedicated approach also for emergency preparedness, because if an accident happens and that's when you start thinking about it, it's probably too late. And here is just another example. It's actually a textbook example of a Natech accident that occurred during the Kocaeli earthquake in Turkey in 1999. So we had a refinery and the earthquake hit that refinery, and we had accidents in several parts of the refinery happening at the same time. So in one place, a very high stack at the refinery collapsed, and while falling, it fell on a pipe rack. And these pipes were carrying flammable substances. So there was a fire there. There was also fire in the crude oil unit due to damage from the falling stack. And then the problem was that they couldn't shut down the fuel supply because the block valves, they couldn't be reached anymore because the fire had broken out, right? At the same time, in the same refinery, due to the earthquake motion, some tanks, the liquid in some tanks started sloshing. This is what we call liquid sloshing. So the roofs basically move, and the roofs are metallic, but the tank body is also metallic. So you have metal scratching on metal due to the seismic motion. And that caused sparks, which led to ignition of these tanks. Actually, 4 of these tanks ignited due to liquid sloshing. Then a flange on one of the tanks broke. We see that a lot too, because you have very rigid tank pipe connections. They break during earthquakes. So some of the substance went out and ignited and went through drainage channels to other 2 tanks that also caught fire. At the same time, at a neighboring fertilizer facility, they had to emergency vent ammonia because they had lost cooling. And ammonia is, if you cool it, it is a liquid, but if you lose cooling, it becomes a gas. So the pressure in the tank increases, and they wanted to avoid the explosion of the tank. So they had to emergency vent that into the atmosphere. On top of that, lifelines were not available. Water mains were broken, water pipes were broken. As I said, there were power and communications problems, and a lot of refinery stuff was unavailable because there was also panic flight behavior of staff who wanted to get away from the facility. And there was also the issue, this is actually an example where they had to evacuate in a radius of 5 kilometers around the facility. Residents and first responders and whoever was still buried or injured or not found, they had to stay there until the emergency responders could go back into that plant. So this is really, as I said, a textbook example of what can go wrong. And you don't see all these things during conventional accidents. So a question that I get a lot is, well, yeah, well, you show me these examples, but is Natech risk really a problem? I mean, maybe it just happens every now and then, it's not a big deal. Well, based on analysis of industrial accident databases that we did with other partners, we saw that about 2 to 6% of the accidents in these databases were Natechs. However, what we also saw is that there is a reporting bias towards high consequence accidents, which means in the databases, you miss the low consequence accidents. So the real number of Natechs is probably much, much higher. And something that we also found is when we say are Natechs a real problem, it may well be that the number of Natechs in the databases is, I don't know, let's assume 2 to 6%, right? We found, however, that the consequences of these Natech accidents are usually much more severe than those of conventional accidents. And to give you an example, we did an analysis of pipeline Natech accidents in the US, and we found exactly 6% of Natechs, right? However, these 6% of Natechs accounted for 18% of economic losses. So yeah, Natech risk is a real problem. And we need to work on reducing that risk. Here is another example, just very briefly, if you wonder if it is a problem. This is a picture of the Houston Ship Channel, which leads from the Gulf of Mexico into Houston, into the highly industrialized areas. You have a lot of oil and gas industry here. And the blue areas are projections of a strong hurricane hitting that area. And the red dots are storage tanks that would be inundated in case of a severe hurricane. So you see the risk is there, it is concrete, and all the more so if we're thinking about climate change, which is changing a lot of the assumptions that went into protecting the facilities as they are now. So what is the status quo in terms of Natech risk reduction? Here, consider that Natech risks, they are sandwiched, let's say, between the natural disaster community and the technological risk community. And we see that the responsibility for managing that risk hasn't always been very clear. Natech risk are technological accidents, which means that the technological risk community needs to deal with them, right? So there is a risk owner, which is good. However, even there, the specific features of Natech risk is often overlooked, especially if we're thinking about a loss of lifelines, loss of safety barriers, and so on. But the good thing is that awareness is increasing, and many initiatives have already been launched or maybe even implemented. And if I take the EU with the 703 directive, which controls major chemical accident risks in the EU, Natech risks are explicitly mentioned there. And then we have other countries, France and Germany, for example, who have their own dedicated strict requirements. But it's good to see that also international organizations have picked up on that problem. I've also mentioned disaster risk reduction frameworks here, because so far what we have seen is that they do not really address technological risks in general, and also not Natech risks. Although with Sendai, I think this is slowly changing, you know, it following an all hazards approach. But something that we've still noticed, and maybe we need to be a bit more patient in that also, that we see that often the focus is still on disaster management and not on disaster risk management. For technological risks, this is not how it works, because what we want to do is we want to prevent the accident from manifesting. But I think we're slowly getting there, and there's some promising initiatives here. Here I put a list of the factors that we think drive Natech risk. One of them is rather the lack of risk governance, which has several reasons. Very important one is probably that Natech risk, you know, it being a very multidisciplinary topic, it cuts across different domains and stakeholder groups. And these stakeholder groups may not necessarily talk to each other, or not normally talk to each other. Something that we also see is an act of God mindset, where you know, we hear things like, oh, but I do not know, or I can do nothing about an earthquake that hits my facility, and so on, which is of course true, but that doesn't mean that you can't do anything, you know, about protecting the facility, right? Then there is something that's called the polluter pays principle within OECD, which is actually a good thing, because it says that whoever pollutes has to clean up and can be held liable, right? However, there is an exemption clause in there, which says that people are liable, you know, to pay for any damages done, for any pollution done, and so on, except if they were caused by a natural hazard that could not have reasonably been foreseen. So to us, this is also a little bit of a problem, and this should be revised. There is a lack of a territorial approach. There is the tendency to say, I have my facility and I look at all the accident pathways on my site, but I don't really look at what is around me. So I have to qualify that I said that because, for example, in Europe, or if you're in industrial parks, you would of course check what is around you. But that's not enough, because as I said, if you lose lifelines, if you lose offsite power and so on, you need to know what to do. You need to be prepared for that. So you need to look at your facility in connection with its surrounding. Then I put here characteristics of Natech risk. We already talked about loss of safety barriers and lifelines by natural hazard impact, which is a huge challenge for emergency management. But the problem is also that if we want to assess that risk, and we want to, I mean, also industry, they want to operate safely and they want to do the best they can. But there is a lack of multi-hazard risk analysis methodologies for Natech and guidance on how to do this. So we're working on that because this is really a big issue. And other factors that drive Natech risk can also be socioeconomic. For example, exposure and vulnerability due to, for example, human development or urbanization. They can increase the Natech risk. You might have community encroachment on natural hazard areas. You have more and more industrialization. So the boundaries, they are not very clear anymore. There might be economic pressures, Natech risk might be considered a low priority. Any implemented measure is not considered self-financing. So it could be considered a long shot risk that might never manifest at all, which is why it doesn't necessarily have to be considered, right? There is a lack of data because often when a natural disaster happens, you wouldn't, as the first priority, try to collect data on technological accidents that happened at the same time. But then there is also the issue of data confidentiality because industry does not often voluntarily share such kind of data, which is a problem because without data, we can't really do much modeling, let's say, or lessons learning. And then, of course, there's the issue of risk perception or risk tolerance. So how much risk is a society willing to tolerate? And when I mention risk perception here, what I mean is that if we have big accidents happening, there's a lot of media scrutiny and civil society scrutiny on the underlying legislation, is enough being done, and so on. But that abates as soon as people forget, when time passes. So this is also a bit of an issue. And then we have a major Natech risk driver here, which I put as the last point, which is climate change. So that is going to do something to the Natech triggers. And these are issues that need to be considered. Here, I put some examples of JRC support to Natech risk management, which is broadly focusing on accident analysis and lessons learning, development of Natech risk analysis and mapping methodologies and tools, risk governance and the preparation of guidance and capacity building. And we didn't just decide one day that this is what we wanted to do, but we actually did a survey of EU member states and OECD member countries and asked them what they thought were the top priorities for Natech risk management. And I want to start with the forensic analysis, and you probably are aware of this saying, which probably appears also in other areas, not only chemical accident management, but it is very true. So it's best to try to prevent and prepare for an event than having to deal with it after it happens. So just a very few slides on this. So the objective of this analysis, of course, is to understand what is happening, to identify the root causes of accidents, contributing factors, exacerbating factors. We want to understand where are the vulnerabilities in my facilities, but also where are my strengths, because this is also very important to know what works, right? And the idea is to learn lessons from that and to develop recommendations so that we can prevent future accident. And we've done a lot of this work with the University of Bologna and also with Kyoto University. And I want to show you just a couple of findings from this. For example, for earthquakes, main damage and failure mechanisms, not surprisingly, direct shaking impact, ground deformation due to liquefaction. We find very high damage severities, which for liquefaction-induced problems is not surprising, but of course, there is the reporting bias and we have to work with the data that we have. We also found a very high ignition probability for earthquake-induced Natech accidents, which increases also the risk of cascading effects. For floods, very similar. What we found, damage failure mechanisms, is on the one hand, the effects due to buoyancy and water drag, impact of floating objects. You see that very well in this tank. Here, oh, sorry, I have to do this, sorry. Something that we also found is that floodwaters distribute toxic or flammable substances over wide areas, which you see very well in the image below, which also ignited. So that was not a very nice accident. What we also found is, interestingly, if you have substances that are released into floodwaters, substances that are not per se toxic or per se flammable, they may become toxic and flammable. And create releases, gaseous releases or fires. What we also found, surprisingly, is that the main Natech triggers in the EU and the OECD were lightning, flood, and low temperature. So who would think that lightning and low temperature were such important Natech triggers? But what this also shows is that you don't need a big natural disaster to cause a Natech accident. Some minor natural hazards are sufficient to cause huge problems. And we also found some commonalities. For example, atmospheric storage tanks are very vulnerable to earthquake, flood, lightning, and storm impacts. So you name a natural hazard, floating tanks, floating roof tanks are vulnerable to that, which is a problem because they're usually very, very big. They have a high tank volume and they contain flammable substances. So this is probably the worst combination. And I'll just show 2 or 3 more slides and then we can break. The good thing is something can be done. So there are possibilities for Natech risk reduction. Here for earthquakes, for example, as I said, instead of using rigid tank pipe connections, flexible ones can be used. That's not a problem. For safety barriers that fail, they also need to be subjected to earthquake design if they are critical, because that's not necessarily always the case. And the most important thing is probably the last one is don't build across or near fault lines, which is exactly what they did here in this image. This is the Trans-Alaska pipeline that goes right across the Denali Fault rupture. In that case, though, use best earthquake engineering practice, because that pipeline here, it was subjected in 2002 to I think an almost magnitude 8 earthquake, Denali earthquake, and it didn't sustain much damage. So they had built that really, really well. Same things for floods. So there are different possibilities for increasing flood resistance, to keep either flood-driven debris out, to make sure that storage tanks do not float, so they can be anchored, but also in terms of emergency response. And this is my last slide before the break. So we have developed our own Natech database because we found that the conventional databases, industrial accident databases, were not really very good at capturing all the details that we need for proper lessons learning. So at the moment it is offline because we're upgrading it, but it's free of charge to use. It's open. You can also put your own data in if you want to. So I hope we'll have it back online in a couple of weeks. So take a look if you want to. And I think maybe we have a break here. Peter?
Yes, thank you very much. So I'd just say to everybody here, I do post your questions into the Q&A box, and do keep those being posted with another opportunity at the end. I mean, at the moment there aren't any Q&As there, but so I actually just had a question about the polluter pay principles. I mean, even though we have the polluter pay principle, actually so often it is the government reluctantly becomes like the insurer of last resort. I mean, if we think of Fukushima, other major accidents where, you know, smaller companies, of course, can't sort of sustain that risk. I mean, do you think that impacts negatively on risk assessment, or is it just these things are, some things are so extraordinary that we do expect the state just have to step in?
We think that it impacts risk management and organizational resilience. It's the same a little bit with this act of God mindset, right? It sounds like a little bit, you know, like an excuse to say there is nothing I could have done. But there is actually a lot that can be done. And I realize the difficulties, especially of smaller companies and so on. But I think the polluter pays principle had a very important role, I don't know, 30 years ago, maybe, you know, when we still didn't have maybe very good natural hazard modeling, when industrial practices were maybe different, but that has all changed. We have very modern industry safety practices now. We have, I think, for most natural hazards, and I guess you know that better than I do, very good modeling capabilities now. So in a way, the polluter pays principle, it seems a bit anachronistic, right? And in any case, I think it's also probably not good for industry itself, because it's not good for their reputation, because we have to assume, and we know, that they want to do their best. And especially we know also from industries we work with, if they have experienced already like flooding or something like that, they are extremely aware of the risks, and they take voluntary measures that go above of what would be prescribed by law, for example. So yeah.
Okay, thank you. But actually, there is a question here, an anonymous attendee, so can't read out who it is. How much investigation should be done in case of disaster risk for Natech? For instance, with the Fukushima accident, TEPCO should have done a comprehensive historical analysis of earthquakes, tsunamis. However, they consider, I think, 500 years, but the region has had that level of earthquakes and tsunamis in the last 1,000 years.
Mm. Well, with respect to Fukushima, I think it was the Diet of Japan, so the government of Japan. If you look at the investigation report, I think they are very clear about what they think was the cause of the accident. So they consider it a man-made accident due to a lot of the shortcomings in terms of preparing prevention or preparedness for that event. I think there's also quite some literature by researchers who say that they should have looked at historical tsunami data much better, because that information would have been available and it might have changed maybe even citing decisions, right? And I remember having seen a presentation by a professor, I think at Kyoto University, where they actually showed that the initial plan for Fukushima was to build it somewhere else at a higher level, let's say, so it would have been more protected, but then in the end they decided against that. I don't remember why that was, but so I think they already put some thought into it and maybe then concluded that the risk was acceptable.
Okay, thank you. So probably close the Q&A session now, and we'll come back to some questions later on. Thank you.
Okay. Okay, then let me try that again. Here we go. I just need to go to the slide where I left off. Right, so here we come to Natech risk analysis. Because, as I said, this is a bit of a problem because it is a multi-hazard risk analysis approach that is required. But in general, if we talk about risk analysis, there are three questions that we need to answer, which is what can go wrong, how likely is it, and what will be the consequences. So obviously, we're doing the same for Natech risk analysis. And here I put 9 steps which come from the University of Bologna. So they're doing quantitative Natech risk assessment. They're developing methodologies for that. And they came up with this table, and the bits in green are those that are specific to Natech risk that you would not find in traditional industrial risk assessment, let's say. And regardless of the assessment approach that you choose, if you say, I want to do a qualitative assessment, I want to do a quantitative assessment, you need in principle these additional parts. So you need these extensions. And if we just go through the steps, obviously you need to characterize the natural hazard on your site. You may find that not all of your site is equally vulnerable. Maybe you have, if we're talking about flood risks, maybe a part is lower lying, which is a problem, but other parts are not, and so on. So for that, you need natural hazards data, which incidentally is also often a bit of a problem for industry, because they know all about industry, but not necessarily about, reading natural hazard maps, and so on. You would then have to identify the critical equipment. Is there equipment that is particularly vulnerable? Is it particularly dangerous, for example? That can depend on the types of substances in the equipment, on the storage or operation conditions, and so on. And then, of course, what you need to do is you need to determine how the natural hazard will affect that specific equipment, and you want to know how likely it is. And here I put in green equipment damage models. So these are models that basically relate a specific damage severity with a probability or with a likelihood, if you will. So that can be fragility curves, for example, and so on. And this is a huge bottleneck in Natech risk analysis, because we don't really have that many equipment damage models. We have a lot for earthquakes, but also for only for some equipment types, but for many other natural hazards, we don't even have that. So this is a big issue. Once you have that information, you evaluate the consequence. So you say my earthquake damages my storage tank, which releases from a 10-centimeter hole a flammable substance, and then what happens? For this, you can use traditional methodologies, that's not a problem. But then comes another big issue, which is, as I said, Natech accidents, they can happen simultaneously, and they can be several in the same facility. So in principle, you would have to consider in your risk analysis all these combinations of events. For example, I have 3 storage tanks and they are hit by an earthquake. It's not only that one might get damaged, but all 3 of them. This needs to be somehow considered. And if you do that in a quantitative way, it's really, really complex. And then you go into your risk integration step, where you just come up with a number in the end. In this context, because it often comes up when I do my risk analysis, obviously I want to be as realistic as possible, because if I only do worst case, I'll probably overestimate the risk and it will be very costly for me. So you want to be realistic. So usually safety barriers would be considered. And with safety barriers, I mean, for example, some containment dikes around storage tanks, or some, protection berms, things like that. It can also be safety instrumentation, high-level alarms, all these things. The problem is, as I said before, an earthquake, a flood, a storm, whatever, they can not only damage your hazardous facility, they can also take out the safety barriers. So they are also vulnerable to natural hazard impact. And we've seen that happen, right? So for Natech risk assessment, we usually assume that protection measures are not available. And we realize that this is a worst case scenario, but we still think it's better to overestimate the risk a little bit than to completely underestimate it. And in this context, I put here the paper of Alessio Misuri, because they've just done a real quantitative assessment of safety barrier performance in Natech scenarios. So this is a really important paper. And this is just an image of, you see the containment dikes here. This is, I think, Hurricane Katrina problems. You see the releases, the sheen of the oil here. So if you have a release in a containment dike is made to keep any releases in the dike inside, but it is not designed to keep floodwaters outside, right? So anything you have in your containment dike, if you flood it, it's gone. It's all over the place, as we can see here. Here I have a couple of representations of risk, of Natech risk. The simplest one, the qualitative one, is a risk matrix. You probably know all about that. The red areas are areas of intolerable risk. The green ones are fine. Yellow ones, you need risk assessment and you need to implement some risk reduction measures. In the image below, this is what our own system, RapidN, provides as output. So that gives you impact zones, so-called endpoint distances up to which a certain physical effect manifests, for example, overpressure or a heat radiation due to fires and so on. And the two images on the right are results from a quantitative Natech risk assessment from our colleagues at Bologna University. One is an individual risk or ISO risk curve, which gives the risk of one person, a person standing in a specific place, in this case around the storage tank, and suffering a certain type of risk. If we're talking more about societal risk, you would use so-called FN curves. So that's a cumulative frequency curves. And they give you the risk or the frequency of N or more people suffering a certain consequence, for example, death. And I think the FN curve here is really interesting because our colleagues did a comparison between unanchored tanks, anchored tanks, and a case study where no seismic risk at all is used. And you see here the risk with no seismic risk at all. The frequency here, we start, what is it, 2 times 10 to the minus 6, more or less, right? And here, if we're talking about risk acceptability criteria, this is acceptable. But if you then consider the seismic risk and then different types of risk reduction measures by anchoring, for example, you see how your risk changes, how your frequency changes. And that curve here puts that specific facility into a non-acceptable risk group. So you see how quickly these things change, because this would then also have consequences on the operation licenses for the facilities. As I mentioned before, we have our own system to understand where Natech hotspots are and how high the risk is. It is not a fully probabilistic or fully quantitative tool. It's semi-quantitative. It screens for Natech risk hotspots. So it's called RapidN. It's web-based, public. You can use it. It's also currently offline. We hope to put it online in the next couple of days after a major system upgrade. Actually would be interesting if you tried it out and you gave us some feedback on that. This is also outcomes of RapidN. So it gives you basically a risk map with the impact zones overlaid on top, and you can either use satellite images underneath because it uses Google Maps, or you just have the map. And here you see another thing. So you can see here, these two storage tanks, these are the impact zones. In the specific case for fire, so these are up to this point, you receive 2nd-degree burns. And you see that it affects also this facility, this neighboring facility here that is in blue. So you can also expect damage there. So in a way, although it doesn't do a quantitative assessment and a formal assessment of cascading effects, RapidN can already tell you where you might need to take a close look in case of cascading risks that you might want to uncover. Then I put here a slide because this is something that we've been discussing recently, and we've also a paper forthcoming on that topic, are Natech accident black swans. And in a way, that's also a little bit the question that you asked before, Peter, also related to the polluter pays principle, the act of God mentality. So it comes down to the fact to asking, are Natech accidents predictable or not? Can we foresee them, right? And I put here the 3 characteristics of what constitutes a black swan. So it has to be an outlier with respect to normal expectations. So in principle, it's not predictable. It has major impact. And in hindsight, you can explain it. So in a way, it is the expression of an unknown unknown, right? Based on our experience, we have not encountered black swan Natechs, but what we have seen is problems with risk management, maybe some organizational blindness towards proper Natech risk management. And we think that saying a Natech accident is a black swan or that it was unforeseeable and so on, it's also a bit, sometimes it can be a little bit convenient, let's say, because in a way it excuses you, you know, from maybe not having done what you should have done to protect your facility. In this context, also here, when you do hazard identification, also non-routine events should be considered. Also, the absence of evidence is not evidence of absence. So just because something hasn't happened yet doesn't mean it cannot happen again. This is an issue for high impact, low probability events, because what happens sometimes, since you cannot protect against all possible accident scenarios, you focus on the ones that are more likely, right? So if a probability is considered very low, you might just cut off there and say, I accept the risk, I do not consider it. This is a problem. This can be a problem for many scenarios, and especially also Natech scenarios. Very briefly, coming into Natech risk management, just a list of what is Natech risk management and the individual steps in it. So you identify a risk, you do your analysis, and then you evaluate the outcome of your analysis against some acceptability criteria. This is also what is called risk assessment. So these three steps together are called risk assessment. And then once you have that knowledge, you go into the risk treatment. So you see what you can do, what are your options to reduce the risk that you have identified. And we have done, we've prepared some guidance in this context. You also see the reference here if you're interested to know more. And my last point here is, how do I measure progress in Natech risk management or a status in Natech risk management? And this is an idea that came from IRDR for the Global Assessment Report 2019. Because the Natech risk trend is not known. I mean, we know the risk is going to increase qualitatively, but we have no quantitative information because there is no baseline for comparing risks over time. And so what we did is we said, okay, let's try some qualitative proxies for measuring Natech risk assessment and see if that makes any sense. And I'll just show them to you. We have, I think, 8 high-level indicators, which all in one way or another, according to our experience, relate to saying Natech risk management exists or does not exist, or is good or is not good. At the moment, we have a table like that, but we're working on refining that. And you can see that we have 4 levels of performance according to the different criteria. The high-level indicators can be divided into sub-indicators, and there we can sort of customize the indicators towards different types, for example, of legislative regimes or different types of conditions, geographic conditions, and so on. There's also more information on that in the paper that I put here, and I'm talking faster now because I'm running out of time. And this is an example application, a 2-country example, because UNDR was interested in having something like this of the indicators. So you can either use these indicators. If I'm one country, I can use it as a simple self-assessment over time because it provides the baseline to check for future progress, or I can compare 2 countries, for example, with each other. And in terms of international cooperation, I mentioned already, we work with OECD, UN, and WHO, and all of them have started projects related to Natech risks and have published some guidance or other types of information. And I really recommend that you take a look at them. They're really, really interesting. And my last two slides, closing the gap. So we still have some research and policy challenges that we have. One relates to awareness, and I think we have discussed most of those already in the previous question and answer and in the discussion, or in my presentation before. Legal infrastructure, unfortunately, risk reduction works best if it is required by law. We would like to rely on voluntary effort, but it doesn't always work that way. But we need the enacting and enforcement of specific legislation for Natech risk reduction plus guidance. I already said we need better risk assessment, methodologies and tools, better damage functions, but we also need to include the impacts on the environment and on the economy, because usually it's human impacts, but the other impacts are interesting as well. Risk governance and risk communication. As I said, we need a more territorial perspective to address the issue. Communication needs to be improved in industry and all levels of government, because there is a lot of fragmentation, even between ministries in the same government. And we need structures for information sharing, as well as access to risk management competence and tools. We need guidance, better data collection, because that's the basis of it all. We need to work on improving knowledge and skills. And of course, also cooperation and partnerships. That is always something that is needed. And that concludes my presentation. Just obviously, I didn't do all of that myself. So we have a team, a very good team. And I've added 2 slides on further reading. If there is an interest from you, you can check out some of these articles. And that's it, really, Peter. Sorry for taking too long.
Thank you very much. No, that's really interesting, and just enough time to answer a few questions quite briefly. We've got one from Richard de Silatonga. He said, what is the most common natural hazard that has triggered the technological disasters so far, and which one has made the worst technological disaster so far?
Well, I think it depends where you are, what kind of natural hazards are in your geographic zone. But at least for Europe and for the OECD, as I showed before on my slide, we saw that the most common Natech triggers were floods, which was kind of expected, but also low temperatures, freeze, and lightning, and that was very unexpected. And in fact, we also asked the survey respondents at the time what they thought, so what their perception was, and they completely missed it. So they all thought storms and earthquakes were the most important triggers, but for OECD countries, for EU countries, they were not. In terms of the worst Natech accident, well, I think what I would have to say is Fukushima and the tsunami. Yeah.
Thank you. So a question here now from Guy Taylor. In terms of risk governance, who is responsible in the EU for thinking about how to implement your research and make sure that risk management is actioned in an effective manner across national borders or site boundaries?
Yeah, what we do is we very closely work with the member states, for example. So since I showed you our rapid and Natech risk assessment system, so we organize training courses with them, for example, so that they can learn how to use it, because they also have to do the Natech, or they have to assess Natech risks to be compliant with the Seveso directive requirements. At the same time, we closely work with the European Union policy DGs in Brussels, who develop legislation together also with member states and so on. So we also have a foot in there, and we work with them to make sure that our work also gets into the whole policy cycle let's say it can take a long time, obviously, because these things always take time, but we try to be there and we try to be present.
And a final question from Gina Charnley. Are you worried that climate change may increase the view that this is out of people's hands and there is nothing they can do to prepare or avoid the disaster?
That's a good question. I don't really have an answer. It is possible. It's possible. Especially because I think climate change, we don't really know ourselves very well. You know, what's it gonna do? I mean, it's gonna have different effects in different parts of the planet, and there might be some things that are really unexpected then. For example, we also have industrial facilities that are now, or that were not in a flood zone, and now they are starting to end up in a flood zone. I mean, we cannot blame them. It's not their fault. It's unintentional. But then one needs to see, for example, if retrofitting is possible, sufficient, if that provides sufficient protection, if the facility can be moved. But that's pretty problematic. Yeah, but I share the concern.
Okay, well, thank you very much indeed. That's a really interesting and fascinating seminar. And I know you're in contact with the IRDR, members of the IRDR, and so we look forward to hearing your research on future occasions. So thank you very much indeed. Well, goodbye to everybody watching and listening on the YouTube channel as well. Okay. Thank you very much.
Thank you.